Okay, here's a couple of questions that deal with quadratics. This first one says solve the equation. So let me just rewrite it again. So x squared plus 9x minus 42 equals 0. My first idea is to factor. So x and x, 42, 7, and 6. Yeah, that's not going to work. 14 and 3, I think. Is that right? 14, yeah, that's 42. Yeah, that doesn't work for 9 either. Darn. So if I can't factor this, so factoring won't work, then I can use the quadratic formula. All over 2a. You have to make sure your equation is equal to 0, and then the thing in front of the x squared is your a, the thing in front of the x is your b, and the last constant number is your c. So x is equal to minus b plus or minus b squared minus 4ac all over 2 times a. So b is a 9, another b is another 9, a is a 1, and c is a negative 42, and a is a 1. So if I simplify this now, I'll get negative 9 plus or minus 81 minus, what's that, 168? Oh no, it'll be plus, because minus times a minus is a plus. 168, I think I said, all over 2. Okay, so that'll be minus 9 plus or minus the square root of, would that be 249 all over 2. So now the square root of 249 doesn't come out even. So I'd have two answers then. One would be negative 9 plus root 249 over 2. And the other answer would be negative 9 minus root 249 all over 2. So let's do that on a calculator. Okay, whoops. There we go. Okay, so I need a bracket. Negative 9 plus the square root of 249. Okay, go over in my bracket and then divide it by 2. There we go. So 3.389. I'm not sure what they said to round it to, but this first one is 3.3898. We'll round it in a second. And the next one, decimals is nice because I can just go and change that minus sign, that plus to a minus. So negative 12.389. Negative 12.389. Okay, and so those would be my approximate solutions. These would be exact solutions, and these would be approximate. Okay, now there's another question up there too. I'll maybe just do this above here. So they say determine the nature of the solutions. So the nature of the solutions, what they're wanting to know there is the graph of the quadratic like this? Does it come down and just touch and go back up? Or does it come back through twice? So this one is 2 real, this is 1 real, and this is 2 non-real. Okay, so I need to find the discriminant, the b squared minus 4ac, using these numbers. So it would be 1 for a, 3 for b, and 8 for c. And if they're real, when I do that, b squared minus 4ac is going to be greater than 0. If I do it and I get the discriminant to be equal to 0, then there's one real number. And if b squared minus 4ac is less than 0, then I know I have two non-real. So let's do that here. So b squared minus 4 times a times c. So b is 3, a is 1, and c is 8. So 3 squared is 9, 4 times 8 is 32. So when you subtract these, you get negative 23. And so that's less than 0. Therefore, I'm going to have two non-real numbers. Now let's just sort of confirm that with decimals. I can graph that. W squared, we'll use x. So x squared plus, I can't hit plus. There, plus 3x plus 8. There. So you can see on the graph, right there on the graph, that the graph doesn't come down to hit the x-axis. It's up above there. So there's no x-intercepts. So the zeros are going to be non-real. All right, hopefully that helps you with those two questions.